Alright, in these two questions we have to rationalize the denominators. So they're two separate questions. I just copy and pasted on the same one. So let's do this one first. First, always check to see if this could get simplified, meaning the radical and the denominator, and I don't think it can. Okay, next I'm going to write out the 12 just like completely factored out. So 12 is 2 times 6, 6 is 2 times 3, so it's going to be 2 squared times 3. Like that's another way to write 12. And then times a cubed times b. Alright, now if we just look at another example, like a simpler example here, like 1 over root 2. Alright, if I was going to rationalize that, I could just multiply by root 2 over 2, because I know that 2 times 2 gives me 4, and that's a perfect square. Alright, so the square root of 4 is 2, and then bang, we got rid of the radical in the denominator. Now this is a little different because it's a fourth root, so we have to get a perfect fourth. So what I would do, there's different ways to do this, but the simplest, most straightforward way to do this is to think of trying to get groups of 4 factors with each unique factor. So like the 2 here is 2 squared, so you need 2 more 2's for it to be 2 to the 4th. Alright, and this 3 is just a single factor of 3, so you would need 3 3's, so 3 cubed, to get to 3 to the 4th. Alright, and then like a cubed, that you need 1 more a for that to be a to the 4th. And then b, that's 1b, so you need 3 b's for that to become b to the 3rd. So what I would, you can't just multiply the denominator like that, so you would have to also multiply the numerator by the 4th root of 2 squared times 3 cubed times a times b cubed. Now, the reason why we do this is because now when you multiply like these together, okay, like 2 squared times 2 squared, both under the 4th root, is going to be 2 to the 4th. And then like 3 times 3 cubed is going to be 3 to the 4th. And then a cubed times a is going to be a to the 4th. And b times b cubed is going to be b to the 4th. So all this purple radical, it's going to simplify really nicely. And then we have in the numerator 12 times the 4th root of 2 squared times 3 cubed a b cubed. Alright, now this is all going to simplify because it's the 4th root of 4 perfect fourths. So like that's all just going to cancel out. Sort of like how like this all just cancels out. Now remember, when you take an even root, so it's the 2 that I just circled, that's because it's a square root, and you get a variable that simplifies with an odd exponent, it's going to need absolute values. So the way we're going to write this in the next step is going to be the same numerator, okay, kind of running low on space here, but it's okay, squeeze that in there, and then the denominator is going to be like 2 times 3 is 6, and then AB, and we're going to keep the AB in absolute values because that was an even root with an odd exponent. The 2 1's were odd. Okay, and then we could take 12 over 6 and simplify that to just 2. So our final answer, if we write it out nicely over here, is going to be 2 times the 4th root of 2 squared times 3 cubed a b cubed over ab. And I don't care if you like leave that like that, that's totally fine with me, but this would be like 100% correct final answer.